right. Our next presenter is Don Grebb, going to be presenting on a better design, FDR and soil stabilization with cement, predictable and economical. Don did a session at the off-site tour yesterday on the soil stabilization and FDR section and did a great job. So look forward to your presentation. He is the principal engineer at Griffin Soil Group, licensed civil engineer and contractor who has been involved in transportation and infrastructure design and construction projects for over 30 years. Over the last 15 years, he has worked exclusively on soil stabilization design and construction applications. Don brings a practical, think outside the box approach, working with public and private agencies, engineers and contractors to successfully incorporate resilient and economic soil stabilization solutions. So, thank you, Don.
All right, thank you, everybody. We're gonna have some fun here. So anyway, better design. I'm gonna share with you all the collective wisdom that I've amassed over the last so odd years from three perspectives. One is from the design perspective, where I started my career doing PS&E, plans and specs, putting those documents together, working with the geotech report, trying to make sense of what the recommendations are, ultimately throw something over the fence, the contractor catches it, wins the bid, and tries to build it. Now I'm on the construction side, dealing with how contractors view those plans coming over the fence and they're bidding them. And what things work best to optimize the best end product. Really, that's what we want, the best end product. And then also from the owner's perspective, who has to ultimately make the decision, do we go with FDR or not? So I'm gonna have fun. I'm gonna share with you all these collective wisdom points, but I'd like to start with a definition. What is FDR? Real plain and simple is a process in which existing asphalt is pulverized in place, blended with underlining base, subbase, blah, blah, blah. I think we've been around, rubbing shoulders with everyone. I realize everyone knows what this means. But the point I want to make is FDR is taken off like crazy. As a contractor, Griffin Soil, especially contractor, we do FDR. And we're seeing a huge uptick in the amount of projects that are being done, coming down and bidding them, which is exciting. That's what we want. But you know what happens when something gets popular? They make a movie out of it. So I happen to have a trailer, an FDR movie. So I happen to have a trailer on it. Can we play that? It's not too long. I think it's gonna be a good movie. Let's see what we got here. It's worth the wait. Blockbuster right there, I'm telling you. Does that make you want to go out and do FDR? That just gets me all pumped up. Okay, so I'm going to share these factoids, these nuggets, these pieces of wisdom with you in a format everyone's used to. Top 10 list. Got top 10 reasons of why FDR is a better design. And so let's jump right into it. FDR is a better design, number 10. FDR is stronger than Class 2AB, provided a bound section. So there's an illustration on the left. You see a traditional design, compacted Class 2, 95%. It's pretty hard, right? It's real hard. On the right, you have a stabilized base held together by the cementitious properties of the cement we added. So it holds together much better. And it's not, the whole thing here is Caltrans has gravel factor equivalent. So this illustrates, you look at here, aggregate base, 200 PSI. You go down to the bottom, there's a relationship between unconfined compressive strength and gravel factors. So we can equate an unconfined compressive strength to a gravel factor and build our pavement section off that given TI. So you can see here in Caltrans acknowledges that. That's how we design our FDR sections. So let me ask this, what's the worst thing for pavements? Did I hear water? Absolutely. Can you control that water? Not always. And Caltrans does a lot of effort to try to put in under drains to capture that water. So that's where FDR really shines. And this theme came across in some other speeches this last 3 days. It's impervious to water intrusion. So water will just accelerate that compacted Class 2AB. But again, we have a stabilized base now. It's held together, but water doesn't influence it. It doesn't break it down, doesn't accelerate any failure. So it's exciting in the sense that you can have a perpetual base there that can be sitting in the water and still not going to fall apart. Here's an illustration of a job we did where permeability was a requirement, along with strength. Needed to get 10 to minus 6 permeability. We were able to achieve that, added 5% cement, had a durable surface for a wastewater treatment pond about 4 hours north of here. So you can see where it's a better design. All right, number 8 reason FDR is a better design. And by the way, these are not in any particular order. I think they're all number 1 reasons, but you can be the judge of that. So number 8. Now I've got my contractor's hat on. FDR construction is predictable over weak, over optimum soils. So this is an example, 3 days from left. We had a project, we show up, they had obviously over optimum. They need to get a load transfer pad to do construction activities. We cement treated that surface, went down 36 inches, provided a load transfer base, dried it up, construction was allowed to proceed. But now I'm going back to the designer, and this is out of a geotech report, an investigation, and they're telling the designer, where unstable, soft, loose pumping soils are encountered, and then below it says, to bridge these, the contractor may consider a number of methods: geogrid, reinforcing fabric, concrete slurry. So as a designer, what do? Well, I came across a set of FAA plans, and here's what I call the terrible, bad, good design alternative. So on the left, and the designer's acknowledging this. As the owner is probably going, wow, what's going to happen when the contractor goes out to build that? Detail A, it says severe pumping subgrade. So they throw fabric, repeat. So digging down to a problem to lay that fabric only gets you closer to the problem source, right? So it's not really a good situation you want to be in. So that's the middle one's bad. It's not terrible, it's bad. Just one layer of fabric and some rock. What I rather do is the good option, mechanically stabilize using cement. So you don't have to over-excavate down to the subgrade to chase that problem, to lay that fabric, to lay that rock. You work from a higher elevation. You saw our reclaimer yesterday. We spread the reagent on there, we mix it, we're working from up here. We're never going down into the subgrade where it's going to be problematic, right? So that's not a condition as an owner, as a designer, as a contractor you want to get involved in. So that's why FDR is a better design, because it mitigates the problems that are inherent to projects where you've got soft pumping subgrade. All right, number 7 reason FDR is a better design. And we just heard from John about LCA, reducing truck traffic and how they beat up your project, the roads going in and out of your project. So reduced truck traffic is one of the positive outcomes of FDR, because you're just bringing cement to the party. You're not bringing aggregates, you're not bringing bad soil out. And the next slide illustrates, well, there's another way to look at it. First of all, one cement truck, 27 tons of powdered cement is equivalent to 40 gravel trucks, 10-wheeler super dumps, coming in and out of your project site, pounding those roads, creating traffic congestion, safety issues, and so on. Here's a way to kind of quantify it, and probably Dave's or John does this, and there's LCAs. Take a 50,000 square foot site, you're going 12 inches deep. The number of trucks to export the spoils there is 120 loads. 146 loads of Class 2 AB has to replace that. It's a lot of truck traffic. If you look at it, actual materials there, close to 4,000 tons of new aggregates versus just over 100 tons of cement. And then the amount of diesel fuel involved to move all that, you can see why FDR is a better design, because it uses the assets that are already there. They don't have to be transported in and out of the job site. And the city, county, whoever, they already pay for those assets, right? So let's reuse them. And the good thing is you don't have to take them very far. All right, number 6 reason FDR is a better design. I love this one. FDR is versatile using the in-situ material, right? The beauty of this is it can be HMA on rock, on subgrade. It can be subgrade on HMA. It can be HMA under subgrade. It can be every combination of that. And the beauty of that is the mix design captures that variability. It takes what's out there, gets the recipe, and then it gets incorporated and built. So a lot of times when you're looking through a geotech report, the words on the left are not something you like to see. Non-spec, we got undocumented fill out there, we got over optimum, contaminated, yeah, contaminated, we can treat contaminated material, and variable material. All things that if you're an owner and you're building a job and the geotech investigation is telling you this, it's not what you want to hear. What you want to hear is the stuff on the right. It meets spec, it's a known pedigree. It's not variable, it's consistent. So the takeaway with this slide is FDR takes the material on the left and makes it the material on the right, bottom line. That's the biggest no-brainer right there. So that's why FDR is a good design. All right, we're down to the bottom 5 reasons. FDR involves the contractor in the mix design. So as a designer, you work with that geotech report, you're doing your best to get a design that's going to work. But you're limited. You only have so much research. You only know so much about the project. So you do what you can. As a contractor, you're taking a design that maybe was constrained. And as a contractor, you say, oh, we could do it this way, or we could do it this way. The beauty of FDR, it includes a step in the specifications that the contractor shall perform a mix design, confirmation. Knowing they classify, characterize the material out there. They figure out what amount of cement has to be added to get the performance. And then that gets run up the flagpole to the RE, and they approve it. So it's an interactive step there that really helps optimize the process. There's no guessing. You're not working with not having all the information you need. Because a lot of times a contractor has better ways of building it, especially if it's phased construction and they're thinking, okay, we want to mill this out, we're going to stockpile it there, we're going to use that to widen those shoulder areas, and we're going to do this and that and so on. And the designer probably had no clue how the contractor is going to build it. So this is a great step in the process. It allows the contractor, designer, to compare notes and come up with a better design. And we do mix designs on all our projects. But basically, it's like I talked about yesterday, we do the potholing, we do the characterization, we do an unconfined compressive strength verification. Maybe it's permeability. Maybe they do some other criteria performance-wise that needs to be met. And then it gets approved. All right, number 4 reason. FDR is sustainable. Yeah, very sustainable. Green, without compromise. This wasn't even in our vocabulary 25 years ago. Green, sustainable, resiliency wasn't on the radar, right? Now it is. It's a big deal too. And so a lot of times someone says, we're gonna build this, it's green. But you think, oh, that's gonna cost more, special glazing, special whatever. The beauty of FDR, it's green, it's sustainable, and it has less cost involved with constructing it because it's recycling, it's reusing what's ever there. So what's a good way to show that something is sustainable? Well, you win awards. And we've won a lot of awards for FDR. This was the city of San Leandro, about 3 hours north of here. Sits close to the bay, bad subgrade, soft bay muds, but good aggregates. And it's an older community and all the roads are feeling the effects. And so we've done many streets in that community and they've won awards with APWA, American Public Works Association. So here's another project not far from there. Last year, won the ASC Sustainable Project of the Year award. This community passed a half-cent sales tax to generate revenue because they knew they get the best bang for the buck by using FDR. And it's really interesting. Older community had what I call developed roads. Started as a dirt road, then they rocked it, and they paved it. And so there was a lot of variability out there. It'd be hard to capture any of that and try to add to it. So the best thing to do is FDR it, make it all uniform, cut out all the variability of that. So it was a real successful project they've been doing for the last 3 years. All right, down to the bottom 3. Granted, this is not a real sexy picture, I'll tell you that. But I think in the essence of what we want in a base, isn't it this? Something that will function that way with no subgrade support but still hold. So FDR creates a perpetual pavement. And again, in line with what John was going over, isn't that what you want? You don't want something that's going to have a limited life cycle. If designed properly, FDR is perpetual. So really, the wearing course is a recyclable aspect of it. So that is truly a better design. All right, bottom two. FDR is a better design. And this is kind of a different one. You probably wouldn't think of this, but when I talk with agencies and they're considering it, and they say, "Oh, who else is doing this? Do you have any other projects? Where else do they do this?" I mean, the last 3 days I've learned a lot, just what else is happening in the rest of the U.S. But take comfort in the fact that FDR is broadly specified, used throughout the nation. And I tell them, I say, I'm not making this up. It's been out, it's documented, it's out there. So it's good to hear that. You can't see this, but this is from U.S. Department of Transportation, Federal Highway Administration. Soil stabilization in pavement structures. A user's manual, design and construction considerations. Do you know when it's dated? You can't see that. 40 years ago, 1979. So, and it's got an old funky mixer on there. So it's evolved quite a bit. The equipment's got more sophisticated, the processes, the specifications. So it's ready for prime time, and it's reflected. We're seeing a lot more projects like this coming out. All right, so we ready for the number one reason? Really, all the reasons are, I think, number one, but what it boils down to ultimately is the cost savings. For all the reasons I stated, right? You're reusing that existing asset that's already there, that already got paid for. There's less import, less export. It's more predictable. That's not a phone call the owner wants to get. It's like, oh, we can't get compaction. We're going to have to rock it and bring in extra fabric. No, it's predictable. It's designed first, and it's built first. No hiccups. It's faster construction. Less traffic handling, less disruption. And it lasts longer, really. That's the goal. We want something that's going to last perpetual, and FDR totally speaks to that. So my goal today is you'll walk away a little knowledgeable with these factoids of information that I talk up when I'm talking with people that are considering FDR. It makes you have a little better comfort level. So thank you for your attention, and got any questions? Good deal.